Hey guys, welcome to Science and Cinema. Today we're going to be talking about time travel in the cinema and in movies. Starting off things, Back to the Future. Back to the Future is without doubt one of my favourite movies. It's one of the coolest movies of all time. However, it's not without its time travel flaws. First of all, let's look at the science behind time travel in Back to the Future. It utilizes wormholes and is reliant on what is called the flux capacitor. Now the flux means the flow of time, and capacitor is the temporary storage unit for that flow of time. It relies on the 1.21 gigawatts of energy or power to operate, and the DeLorean must reach a speed of 88 miles per hour for it to be able to travel through the wormhole created by the flux capacitor. This kind of time travel does have dangers, which come in the form of what's known as paradoxes. Now, a paradox is, to give you a definition, a statement or proposition that seems self-contradictory or absurd, but in reality expresses a possible truth. Now, that's a little hard to understand. One way I managed to get my head around the wonderful world of paradoxes was by watching a Stephen Hawking's documentary on time travel, where he discusses the great improbability of using wormholes and the dangers associated with them. He explained this by putting his own spin on what is known as the grandfather paradox. So essentially what he said was, imagine you had a mad scientist who created a wormhole that went exactly 1 minute into the past. And this mad scientist wanted to test what would happen if he created a paradox. So he stood on one side of the wormhole, loaded a gun, walked around to the other side of the wormhole and shot himself through the wormhole. Now, he shot himself before he had had the chance to load the gun that he used to shoot himself. It doesn't really make sense. It's a paradox, and it's for these reasons Hawkins believe that wormholes cannot be sustained on such a large scale or used to travel through time. The way in which they bring about paradoxes is what will fundamentally cause them to destroy themselves. Why Hawkins believes that this breakdown of the laws of physics through the use of a wormhole is extremely unsustainable. He describes it being much like feedback in a speaker. So what happens with feedback in a speaker is a piece of sound gets caught in a loop between the microphone, say, and the amplifier. And it goes back and forth in a continuous loop until it comes out as that high-pitched screech noise. Now, sometimes it gets too fast or it gets too large of a sound, so it doesn't come out the amp as that noise. It continues to bounce back and forth in this loop until it gets so powerful or so full of energy that the speaker blows and the whole thing destroys itself. It's much the same principle, he says, with a wormhole. Whereas once it's created, it's likely that radiation will just get caught in a vicious loop through the wormhole and get greater and greater until it just destroys itself. It's not sustainable. Okay, so it is fun to look at, I guess, wormholes and all that kind of stuff. But let's take a look at some films that explore time travel a bit more realistically, even though they may not have intended to, or they're still quite far-fetched, but they get closer to the truth, I guess, than Back to the Future did. An example I could find that related to Einstein's theory of relativity, which I'll touch on in a sec, was in Star Trek VI, The Voyage Home. And what has become to be known as the slingshot effect they used in the film, the crew utilized the immense gravitational pull of the sun to warp time as they traveled around it in an orbit and travel back and forth between the past and the future, essentially. And the reason why this isn't so far-fetched is because of Einstein's theory of relativity. And what his theory of relativity says is that time and space are linked, but they also time flows much like a river. And so this is achieved in a river by variations of width from shore to shore. So in space, this is achieved by a large mass and gravity. The heavier an object, the greater its pull on time is. The heavier mass of a planet or black hole is like the wide areas of the river. Time flows slowly in these areas. So in essence, if you were to travel to a black hole and somehow manage to get, not to get sucked in, but travel instead into an orbit, you could potentially travel through time, as your time around the black hole is passing much slower than that on Earth. Therefore, let's say 5 years of orbit of a black hole would be 15 years of Earth time. Whereas this is quite cool and extremely plausible, it's not a very effective means of time travel for a few reasons. One, black holes are extremely hard to find. Two, they're extremely far away, so you'd probably spend light years trying to get there for only a few years difference in time. And three, they're extremely dangerous. You're most likely to get pulled into a black hole rather than into its orbit. A lot of Hollywood films seem to focus heavily on time travel to the past. I think this is because of its ability to bring about paradoxes and thus, I guess, create a more interesting, dangerous story. However, I think, or I'd like to see a shift, I guess, to a more scientifically accurate portrayal of time travel. Einstein's theory, it is possible to travel into the future if you can reach a speed close to the speed of light. Again, I'm going to regurgitate the words of Hawkins here because he is the basis for most of what I know. But he put it pretty much like this. The universe has a cosmic speed limit, which is the speed of light. And nothing can usually reach or pass, definitely not pass that speed. So say if you had a vessel like a train and a track that went in a straight line around the entire Earth in a continuous loop, and some exotic form of energy with amazing potential to speed this craft up, it is possible to accelerate that craft to 99.9999% of the speed of light. But there is a flaw with that, because if you're on the inside of the train, say, this is how Hawkins put it, if the train is traveling at 99.99% the speed of light, and a little girl stands at the back of the train, and she runs to the front of the train, her velocity is then added to the speed of the train, which means that could essentially push it over that 0.001% and surpass the speed of light. This cannot happen for one main reason, because once the train reaches that speed, time is warped. Time on the inside of the train actually slows down greatly to stop that from possibly happening, to stop the little girl's velocity adding to the train and causing it to move past the speed of light. So, as he put it, if this train sped up around the Earth and travelled for 100 years at close to the speed of light, those on the inside of the train would only experience 1 week of time for 100 years of travel. That, I think, is the closest we know that we can actually get to time travel, although the technology behind that is quite advanced and we're well away from that. That being said, you can only go one way. You cannot come back unless we are able to utilize wormhole technology. Again, though, that's extremely dangerous and very, very far-fetched. The future is much more viable than the past. It still requires great advances in technology, and who knows, maybe one day we'll be able to harness the power of a wormhole and move freely about in time and space. But until then, we can only write and make movies about it.